Hello students. So I'm back to make a video of this warm-up, but I hope that you've tried it and struggled with it a bit before coming to watch this video because it is a nice meaty problem. So my hint in the video about radians was that we're told to find the cosine of DAC in exact form. So we want a ratio. We're not looking for that angle. But first of all, let's draw the picture so we know what we're talking about here. So we've got a triangle ABC whose sides measure 3 meters. So it's our equilateral triangle. Oh, let me try that again. All right, I'm going to put in the triangle. Know that we want D to divide BC in the ratio of 1 to 2. So I want my BC to be in the bottom here. Put BC on the bottom, put A up here. And then D is dividing it in the ratio of 1 to 2. So this is going to be 1, this is going to be 2. That's my point D. I'm going to connect it up to A. And I'm doing that because I want angle DAC. So this is the angle I want. Typically we use theta as our variable for angles. So I'm going to put that there. My other sides are 3. And because it was originally an equilateral triangle, I know that this angle is 60. So we're told that we want cosine of DAC in exact form, but first I want to think about the question of how are the sine and cosine ratios related? So we know that it doesn't matter what kind of angle or what kind of triangle we're talking about, that sine 30 is always sine 30 no matter what type of triangle it is in. Sine 75 is always sine 75. But I can think about my right triangles to help me answer this question of how they're related. So I know that in a right triangle, sine theta is opposite over hypotenuse. In a right triangle, cosine theta is adjacent over hypotenuse. And Pythagorean Theorem tells me that opposite squared plus adjacent squared is hypotenuse squared. So I can use this to help me. If I divide both sides by h squared, then I would get that opposite over h squared plus adjacent over h squared is 1. Well, this is sine, this is cosine. So I can say that cosine of theta is equal to a over h, or rearranging this, a over h is the square root. Ooh, that did not do what I wanted. Think about relating a sine ratio to a cosine ratio. So I know cosine of theta then would be equal to this. I can also say that cosine of theta is square root of 1 minus sine squared theta, because of course opposite over hypotenuse is sine theta. So if I square it, I get sine squared theta. All right, so this is something that we need to know. I'm going to move this over just to have some more space. Okay. So let's think about our triangle here and what we see. Well, the first thing I see is 2 sides and an angle. 2 sides and an angle make me think about area. So I know that the area, of triangle DAC is 1/2 3 times 2 times, not cosine, sine, of 60. Sine of 60 is one of my special angles. I know that's root 3 over 2. So this half cancels with this, and I'm going to get 3 root 3 over 2. Well, the other way that I could bring in my theta is that I could say that the area of the triangle is also using these sides. I don't know the length of this side, so I'm going to use x. So I could say that it's also equal to 1/2 of 3 times 2, not 3 times 2, 3 times x times sine theta. So then I'll get that it's equal to 3x sine theta over 2. Well, this implies then So my 3 and my 2 are going to cancel. So sine theta is root 3 over x. Well, that of course means that cosine theta, following this rule, is going to be square root of 1 minus root 3 over x squared. All right, let me make this square root sign a little bit bigger because I'm square rooting all of that quantity. Well, I know that cosine theta also appears in the cosine rule. So I could either set up my cosine rule with my cos theta here, or I could set up cosine rule with my 60-degree angle and say that x squared is equal to 3 squared plus 2 squared minus 2 times 3 times 2 cosine of 60. Well, that's going to lead to 9 plus 4. Cosine of 60 is a half, so that's going to cancel. So 9 plus 4 minus 6, that's 7. So x is the square root of 7 because I know that x is positive. It's a length of a triangle. Now that I know that, I can come in and plug in. I'm going to get square root of 1 minus root 3 over root 7 squared. Well, of course, that's just 3 over 7. So I get square root of 4 over 7, which I could rewrite as 2 over root 7, or conversely, I could write that as 2 root 7 over 7. Either of these two answers is the best, and I have found cosine theta.